I want you to imagine you are standing on the shore of a dark ocean at night. You pick up a rock. It feels heavy in your hand. It has sharp edges. It is solid. You throw it into the water. Splash! The rock sinks. It is gone. It is in one specific place at the bottom of the sea. Now imagine you shout into the dark. Hello. The sound leaves your mouth. It doesn't sink. It spreads. It becomes a ripple in the air, expanding in a sphere, touching everything at once. It has no edges. It has no weight. It is not a thing. It is an event. For thousands of years, we believed the universe was divided into these two categories. There were particles, the rocks, the atoms, the planets. Things that are solid, localized, and distinct. And there were waves, sound, light, ripples on a pond. Things that are fluid, spread out, and ethereal. A thing could be a rock, or a thing could be a ripple. But a thing could never, ever be both. That would be like saying a person is both a statue and a song at the same time. It is a logical contradiction. But in the early 20th century, we opened a door that we should have kept closed. We looked too closely at the building blocks of reality, and we found something that terrified us. We found that the universe is suffering from a split personality disorder. We discovered that if you look at an electron one way, it hits you like a bullet. But if you turn your head and look at it another way, it flows around you like water. We discovered that the solid world you are sitting in right now is actually made of vibrations. We discovered that reality doesn't know what it is until you ask it. This concept is called wave-particle duality. It is the central mystery of quantum mechanics. It is the glitch in the simulation that suggests matter is just a condensed form of music. Today, we are going to decode this paradox. We are going to trace the detective story from Isaac Newton to the quantum eraser. We are going to find out why light behaves differently when you watch it. And we are going to ask the question, if we are made of waves, why don't we ripple? If you want to join us on this journey into the impossible, and you want to make sure you rehear when we finally crack the code of the universe, go ahead and hit that subscribe button. We are uploading deep dives into the unknown every week, and you don't want to be left in the classical world. To understand the paradox, we have to understand the war. In the blue corner, weighing in with the authority of the gods, was Sir Isaac Newton *. In the 1700s, Newton wrote a book called Optics. He argued that light must be made of particles. He called them corpuscles. Newton was a giant. So for 100 years, science said, light is a particle. But in the red corner, there was a rebel, Thomas Young. In 1801, Young looked at ripples in a duck pond. He saw how two waves could crash into each other and create a new pattern, an interference pattern. If two wave peaks meet, they get bigger. If a peak meets a trough, they cancel out to zero. Young thought, if light is a particle, two beams of light should just make a brighter spot. But if light is a wave, two beams of light should be able to cancel each other out and make darkness. He performed the famous double slit experiment. He shone light through two slits. And on the wall behind, he saw the pattern. Bright, dark, bright, dark. He had proven that you could add light to light and get darkness. It was impossible for particles to do that. You can't throw a rock at a rock and make them both vanish. So Newton was dethroned. The world pivoted. Science said, We were wrong. Light is a wave. Case closed? Not quite. Fast forward to 1905. A patent clerk named Albert Einstein is having a very busy year. Basically, if you shine UV light on a piece of metal, electrons fly off. It's like kicking a ball out of a pit. If light is a wave, then a dim light, a small wave, should eventually knock the electron out if you wait long enough. The energy should build up, like water slowly filling a bucket. But that didn't happen. A dim UV light knocked electrons out instantly. A bright red light, wrong frequency, did nothing, no matter how long you waited. It wasn't a continuous wave washing over the metal. It was a stream of tiny, discrete packets of energy. He called them quanta. We call them photons. Einstein won the Nobel Prize for this. He proved Newton was right. Light is a particle. But wait. Young proved light is a wave. Einstein proved light is a particle. They were both right. They were both supported by irrefutable evidence. This was a disaster for physics. It's like looking at a cylinder. From the side, it looks like a square. From the top, it looks like a circle. Is it a square or a circle? It's neither. And it's both. It's a cylinder. Chapter 2. The Matter Wave, de Broglie's Dream. Asterisk, asterisk, in 1924, a French prince, literally a prince, named Louis de Broglie, had a crazy idea for his PhD thesis. He looked at the mess with light and thought, if light, which we thought was a wave, can act like a particle, maybe matter, which we think is a particle, can act like a wave? He wasn't talking about photons. He was talking about electrons. He was talking about protons. He was talking about atoms. He wrote down a simple equation. Lambda is wavelength, is momentum, mass x velocity. This equation says that everything that has mass and moves has a wavelength. An electron has a wavelength. A molecule has a wavelength. A baseball has a wavelength. You have a wavelength. Instead, they diffracted. They bent. They created an interference pattern. The electron was wiggling. This changed everything. It meant that the solid universe is an illusion. The atoms in your body are not static points. They are smudged out in space. The only reason you don't see a baseball rippling through the air like a ghost is because of de Broglie's equation. Look at the math. The wavelength is inversely proportional to the mass. The bigger the mass, the smaller the wave. An electron is tiny, so its wave is big, relatively. A baseball is huge, so its wave is infinitesimally small. It is smaller than a proton. It is so small that for all practical purposes, it is zero. This leads us to the heart of the paradox. The moment where the universe stops making sense. Because if matter is a wave, what happens when we try to watch the wave? Chapter 3. The collapse, the identity crisis. Asterisk, asterisk, let's go back to the double slit. But this time, let's do it with particles of matter. Electrons. We fire electrons at the two slits. We don't watch them. We just look at the back wall. Even if it's a wave, does 50% go left and 50% go right? Does it split in half? They decide to put a camera, right next to the slits. They want to spy on the electron. They want to see the path. They turn on the electron gun. They turn on the camera. Electron 1 comes through. The camera goes beep. It says, it went through the left slit. Electron 2 comes through. Beep. Right slit. When we don't know the path information is unavailable. The electron is a wave of possibility. It explores all paths. When we do know the path information is available, the electron collapses into a single reality. It is like a video game that only renders the graphics when you look at them to save memory. Or ... It's like the universe is gaslighting us. I wasn't a wave. I was a particle the whole time. Look, you can see me. This drove physicists into a philosophical crisis. Niels Bohr, the father of the Copenhagen interpretation, said, "There is no quantum world. There is only an abstract quantum physical description." He meant that, until you measure it, the electron does not exist in a real sense. It is just a math equation. But Albert Einstein hated this. He famously said, "I like to think the moon is there, even if I am not looking at it." He believed there must be a hidden variable. It suggests that the electron is a real particle. It always goes through one slit. It never splits. There is a ghostly guide wave that permeates the universe. The particle rides this wave like a surfer. When the wave hits the two slits, the wave goes through both. The wave interferes with itself on the other side, and the particle riding the wave gets pushed around by that interference. If pilot wave theory is true, reality is not broken. There are no ghosts. There is just a surfer on a strange ocean. It is a beautiful logical solution. But ... there is a catch. There is always a catch. For pilot wave theory to work, the wave has to be instantly connected to everything else in the universe. It requires non-locality. And just when we thought we might understand it, we have to talk about the quantum eraser. Asterisk, asterisk. Photon A, the signal, goes to the backscreen to make the pattern. Photon B, the idler, goes off in a different direction to a set of detectors. Here is the genius part. Photon A hits the screen first. It has already landed. Its journey is over. It has recorded a dot on the wall. Photon B is still flying through the experiment. It hasn't reached its detector yet. We can choose to do two things with photon B. 1. We can catch it in a detector that tells us it came from the left slit. We keep the information. 2. We can send it through a scrambler that erases the path info. It's like flipping a coin on Tuesday and having it change the result of a lottery that happened on Monday. It violates causality. The effect happened before the cause. Does this mean we can send messages to the past? No. The universe covers its tracks. You can only see the pattern when you compare the datasets later. But it suggests something profound about wave-particle duality. It suggests that time is not a rigid arrow for quantum particles. The photon doesn't have a history until the information about that history is finalized. If the information is available, it was a particle. If the information is erased, it was a wave. History is not written in ink. It is written in pencil. And as long as the eraser is still on the table, the past can change. Imagine you are a celebrity, a superstar. When you are alone in your house, with the curtains drawn, you can be yourself. You can wear pajamas. You can sing off-key. You can do whatever you want. You are in a superposition of behaviors. But the moment you step out the door, the paparazzi are there. Flashbulbs popping. Cameras clicking. You freeze. You put on your public face. You act solid. You act defined. In the quantum world, the environment is the paparazzi. And the paparazzi are everywhere. Air molecules bouncing off your skin. Photons of light hitting your face. Heat radiating from your body. Every single one of those interactions carries away information about your location. An air molecule hits you and bounces off. That air molecule now carries the secret of where you are. The universe knows your position because you are constantly leaking data into the environment. This is decoherence. An electron in a vacuum can be a wave because it is isolated. It has no paparazzi. It keeps its secrets. You are a massive object made of trillions of atoms interacting with trillions of air molecules every nanosecond. You are being measured by the universe billions of times a second. Your wave function is collapsing so fast instantly that you never get a chance to ripple. You are being bullied into solidity by the atmosphere. This is why quantum computers are so hard to build. To make a qubit, a quantum bit, stay in a wave state, we have to freeze it to near absolute zero and shield it in a vacuum. Chapter 6. The Universe is Code. Information Theory. Asterisk, asterisk. It isn't about shapes. It isn't about ghosts. It is about information. This is the modern revolution in physics. We are stopping thinking about matter and starting to think about bits. John Wheeler, one of the great physicists, coined a phrase, asterisk, asterisk, it from bit. Asterisk, asterisk. He meant that every it, particle, force, object, derives its existence from bit. Yes, no answers to measurement questions. Reality is not made of hard stuff. Reality is made of answers to questions. Think about a video game. In a video game, the computer doesn't render the entire world at once. That would crash the processor. It only renders what the player is looking at. If you look at a tree, the computer calculates the geometry of the tree. If you turn away, the tree exists only as code on the hard drive. It exists as a probability of a tree. Wave-particle duality looks suspiciously like a rendering optimization engine. When the universe doesn't need to define a specific location, no path information, it saves processing power by treating the object as a probability wave. When the universe needs to define a location, because of an interaction measurement, it renders the particle. This is why the eraser experiment works. If you delete the data, the universe says, "Oh, I don't need to render that specific path anymore. Let's revert to the wave function." It sounds like a conspiracy theory. It sounds like the Matrix. But it is the most logical explanation for why information plays such a central role in physics. Black holes, entanglement, duality, they all come down to how information is stored and transferred. If this is true, then wave and particle are just user interface graphics. The wave is the source code, the raw data, the potential. The particle is the display on the screen, the result, the reality. We are living in a universe that is fundamentally digital. The third state asterisk, asterisk. So let's pick up that rock again. We now know the answer. It is neither. The rock is a temporary disguise worn by a wave, and the wave is a mathematical description of what the rock might do. It teaches us that reality is not something that is just sitting there, waiting for us. Reality is a participatory act. By interacting with the world, by observing it, by breathing the air, we are co-creating the solidity around us. It allows for the freedom of the wave and the certainty of the particle.